This is video 2 of the Psych 642 Factorial ANOVA assignment. In this video, I'm going to begin going through the R code line by line and running it to get the results of this study. So the first thing that I need to do is attach the data set that I imported at the end of the last video. And I'm going to do that using the attach function. So I'm going to run that. The next thing I have to do is set up the two predictor the two predictor variables as factors. So I'm going to use the factor function to do that. You can see that I'm specifying the name of the variable that I'm looking at, as well as setting the levels. Each of them have two levels, and then giving each level their label of male and female treatment 1 and treatment 2. So I'm going to go ahead and run that. And you can see that it's changed over here into a factor with two levels, as well as if we go and look at the data set, you can see that the 1s and 2s have been changed into their appropriate labels that that I set up using that code. Alright, so now that the data set is attached and the factors have been created, next thing is to just kind of look at the data, look at what it looks like, and test some assumptions. So to start off, I'm just going to get the descriptive statistics, and I'm going to do a few different things here. I'm going to start by getting the descriptive statistics by gender, and then by type of therapy, and then I'm going to use the list function in here to get the descriptive statistics for the groups that arise as a result of the interaction between gender and therapy. So I'm going to do all three. I'm just going to run that quickly here. You can see all that's appearing down here in the output, and we'll come back to that later. So now that we have the descriptive statistics, I want to test for two of the assumptions. The first is the assumption of normality. Second is the assumption of homogeneity of variance. So first, I'm going to use the by function along with the Shapiro test to determine if the data is normally distributed within the groups. So the first way I'm going to look at this is looking at the distributions by gender, then looking at the distributions by type of therapy, then looking at the distributions for the interaction between gender and therapy. I'm once again using the list function. So I'm going to go ahead and run the first one. We can see that when we separate the distributions by gender, the distribution of anxiety score by gender, we do meet the test or the assumption of normality. When we do this by type of therapy, however, the treatment 2 distribution does come out to be significantly different. So the p-value there is less than 0.05, which means that that distribution for treatment 2 does differ significantly from the normal distribution, which is a problem for running this test. And I'm also going to run for the interaction, which once again also has one group that has a non-normal distribution. We're looking at the interaction between male and treatment 2. So both of those are problematic and could signify that the results that we get may or may not be accurate. And I'm going to go ahead and push forward and go ahead and do the Levene test as well to check for homogeneity of variance. It's set up the same way as I did the Shapiro test, except it uses the Levene test function. I'm looking at it at the distributions broken down by gender, then by therapy, then using the interaction function embedded within the Levene test function, looking at the interaction between the two. So when running the Levene test with gender as the grouping variable, it is not significant. However, when running it with therapy, it is significant. And then also, it is significant when running it with the interaction. So there are some assumptions about the homogeneity of variance and the assumption of normality for all of these groups is not met for this specific data set. But we're going to push through and do the test anyway, just to show what the process for doing the test is like. So as was the case with the ANOVA, before we can set up the model for the ANOVA, we have to take into consideration what types of contrasts we want to use, as well as what types of sums of squares we're going to use. Because just like with the ANOVA, the order of the variables in the model does make a difference, and R uses type 1 sum of squares by default, which is problematic because of the order issue here. So I'm going to use type 3 sums of squares, which means that I have to set up contrasts that are orthogonal in nature. So these next two functions, or these next two lines of code here, I'm doing exactly that. I'm setting up the contrasts for both gender as well as therapy. Okay, so now that that's been done, I can use the AOV function to create the object that specifies the model. And you can see here I've put the outcome variable is anxiety score, which is our continuous variable of anxiety, and then the two predictor variables, gender and therapy. The asterisk in between them here means that it's going to include gender separately, therapy separately, and then also the interaction between gender and therapy when creating this model. And then of course the data is coming from the anxiety treatment data set that we imported from Excel. So I'm going to go ahead and create that model. So as I just previously mentioned, I'll be using type 3 sums of squares for this model. So I need to use the ANOVA function with the model in order to do that. And as I'm going through this, I see that there's a mistake in the code here. I do need to specify the type in order to get this to work correctly and use type 3, which it appears I had left out here. So now that that's in here, I'm going to run the model using type 3 sums of squares. And you can see the output down here, which we will go over a little bit more in detail towards the end. But it appears that gender does have a significant main effect on anxiety score, and there's also a significant interaction effect. However, therapy, which you can see here, does not seem to have, or the type of therapy does not seem to have a significant main effect on the outcome of anxiety. So now, even though I don't necessarily have to do this for this specific study for a couple of different reasons, there's only 2 levels of each variable, so I don't really need to do a contrast there because the information is already right here, as well as I'm really more interested in looking at the specific details of this, which the plan contrast that I've already set up won't do, but I'm going to run them anyway, just so, using the summary.lm function, just so we can see what we have. So once again, gender is coming up, significant, so there is a difference there. And then once again, also the interaction effect is coming up, significant as well. Now, one of the next steps, since we did have a positive significant interaction effect in this ANOVA, is looking at the simple effects. So what the simple effects analysis allows us to do that the overall ANOVA model and the plan contrast we just ran do not let us do is it allows us to look at the effect of one of the independent variables at the individual levels of the other independent variable. So for this study, I specifically asked the question of whether gender affects the effectiveness of either of these therapies, right? So that is the specific simple effect analysis that I'm going to be looking at. I want to look at the effect of gender at each level of therapy. So in order to do this, in R, it's kind of tricky. You have to create a new variable that includes both of the predictor variables in one variable. So I've done this, and I've named it simple and added it to the data set. So there's 4 different groupings whenever you combine the two together. There's males that got treatment 1, males that got treatment 2, females that got treatment 1, and females that got treatment 2. And then there's 12 individuals in each group. So this is setting up this variable to have 4 different groups with 12 in each group. So I'm going to go ahead and run that. Then, just like I did with the other predictor variables, I'm going to go ahead and factor that and give it the labels. So this it once again specifies that there's 4 different groups or 4 different levels within the factor of simple that I've just set up, and I'm going to label them MT1, MT2, FT1, and FT2. Now I have to set up the contrast that I want to use to look at the simple effects. So overall, I just want to look at a treatment effect. Is there a difference in the 2 treatments? And that's set up here. So I'm going to go ahead and run that. The next thing that I'm going to be looking at within each of the treatments is whether gender had an effect. So is there a difference between males who got treatment 1 and females who got treatment 1, which is what I'm doing now, and whether or not there's a difference between males who got treatment 2 and females who got treatment 2, which I'm going to do now. So all 3 of these that I've just defined need to be bound together into one value for the contrast. So I'm going to do that next and call it simple F. There we go. So now I'm going to set the values of simple F as the contrast for the variable simple that I created, which you can see is what this line of code is doing here. Okay, so now that's set, and now that the contrasts are set up, I can create